Does still not work for this yet? Oh, come on.
Having issues there.
Yeah, it worked with the app for a little while, and now it looks like it's not working again.
Uh, yeah, I'm not using it today. I'm on my PC. Wonder if they're working on a PC version for the app too. All right. Okay, cool. We are recording, so let's get things rolling. Welcome to the virtual brown bag. As usual, quick note that we do record these meetings so that we can, later share the recording with other folks who couldn't attend the meeting, or maybe we need to review content that we've discussed here. So just make sure that, if you're sharing thoughts or screen or anything, don't share anything that could cause you any kind of trouble. The Virtual Brown Bag is a place where we get together, we share tips and tricks, experiences, frustrations, difficulties, usually related to software development. At times we talk about other things that are not just necessarily coding or technology. It could be process-related things, and you name it. It's all a fair game for us here. Every Thursday, 12 to 1 Central Time, here on Skype. Everybody's more than welcome to join in and participate. This is a partial list of topics that we've covered over the years. We've been all over the place, so you can see we've gone through like Azure things, Sapper, architecture, arrange act assert, given when then, gherkin, Pomodoro technique, testing node, and it's really everything or anything that we feel like sharing with folks who are in the call. We have a virtualbrownbag.com website where you can always find the link to this meeting, as well as the link to the videos for the previous meetings that we've had at the bottom of the page if you keep scrolling. You can also find the link to the Slack channel where you can post like ideas you might have that you would like to share with folks here, or maybe continue the conversations after the meeting is done. There's a channel for that. And other than that, let's roll. What are you guys up to?
Well, let's ask others first. I've got some stuff I could talk about.
Sure.
What's everyone else up to? Anyone do anything cool? Anyone have questions they want to ask that we can focus on?
I'm Maxwell, by the way.
Nice to meet you. Welcome. Thanks for joining us.
Thanks for having me. Yeah, I'm like a pretty recent grad of Operation Spark in New Orleans. So, yeah, just coming to check it out. Right now, I'm in the job hunt. Been in the job hunt for about 6 weeks or so. So yeah, technologies I work with, like pretty much JavaScript all over the stack. So Node, Express framework, Vue, and React on the front. General stuff like that. Right now, I'm doing a couple things. So I'm learning how to test my code more. That's one thing that wasn't covered a whole lot, although we did have to like kind of write some tests, but it was, not serious. Like I'm trying to figure out how to do I'm trying to create some stuff with like trying a test-driven development approach for like really simple projects. Trying to learn Python within like 2 days for for a coding challenge, but seems pretty easy to pick up. But other than that, I'm working on a chess tactics application, and that's it for me, really.
Nice. That's pretty cool. That's it's a common experience I share with folks about like TDD. At times it's like people who are just starting to learn about software development, they seem to have an easier time starting from TDD and writing the specs before writing the code. Older folks who have been doing this for a long time and have been like writing the code first, they tend to have a harder time, right? And then usually, we take a course on, how to do TDD and everything, and then writing tests first for very simplistic scenarios. Yes, it's easy. And then we get into the real world and we're working with a legacy system with a lot of baggage there. Everything breaks down and then we give up on the practice. So it really takes time. And many times when that is the case, when I'm working, coaching somebody who has been doing this for many years, I say, okay, forget TDD for a moment. Let's look at actually writing tests for what's there. Because then we're going to learn how hard it's going to be to write tests for legacy code, right? Because we're writing tests for things that were not designed with testability in mind. So that way we get to learn, why is it so hard? Why is it that people look at it and it's like, oh, it cannot be tested because look at this one class here that has 1,000 lines of code. How do you write tests for that? Right? So learning from that angle, and then we can eventually flip it around, and then it starts to make more sense as to why we should be thinking about the specs before we write the actual code. And again, that's been like my experience from my background. George, you've been working with a bunch of guys who are just learning this thing. What has been your experience with that?
Well, so I mean, like Max said, like Operation Spark doesn't really teach TDD, which is a shame. And but it's a very compressed curriculum, and how fast, it takes like a year of practice to get actually good at TDD and like a daily practice. So right. I do wish we'd focus on it more, but I understand why we don't. I will say, like, one thing I'll tee off of that conversation is not only, like, I don't actually even think the difficulty is so much I have the class and I don't know, and like, this is so complex, how do I test it? Because while that is true, like, once you have a little experience, you can just refactor it and see the matrix there. The bigger issue is usually that you're looking at a 1,000-line class and you're like, I don't know what this is supposed to do. I don't know what it does matches what it was supposed to do. And I don't know if what it doesn't match what it's supposed to do because the person writing it made a mistake, or because they saw something that, their boss was telling what it should do, did it, right? Which is like, all those things happen with equal probability. So it's really, really, really hard. And so to me, TDD is almost more about the record of your intent than it is about just testability, right?
Yep.
Interesting.
Yep.
Yeah. Oh, go ahead. Oh, yeah, I was going to say, I found it really tough in exactly that kind of way, because I was like, man, I have to define my intents before. I'm like, I have to know what this thing's going to do even before I touch it. It's like, man, this is actually way harder conceptually, really, than like, yeah, writing the code and then writing the test afterwards. It's like, oh yeah, it does this, it does that, it does this. But trying to conceive of it beforehand has been a real challenge.
Mm-hmm.
Right.
Yeah. Yeah. And that sort of stuff, I mean, that's the sort of stuff people aren't good at in general. And that's in large part like what it is we're training ourselves to do is this thing that's clearly important, but that just is not evolved into us at all, really. Like, we don't ever have to tell anyone exactly what we mean, except to the computer. Yeah. So,
Wow.
I was big TDD fan. Claudia, you're a big TDD fan. Definitely do that. Are you doing TDD mostly in JavaScript, or are you bringing that to your learning Python as well?
No, just in JavaScript right now, because I've got there's another coding challenge I'm looking into, which is it's timed. It seems like it's going to be pretty basic. It's just building like a JSON API, which I've done before, but in the rubric, what it wanted tests and stuff like this, so on and so forth. And actually, that last coding challenge that I did, I meant to write you, but I also kind of felt a little bit stupid. It's like one of the things they mentioned was that the tests weren't complete enough. They're like, yeah, the testing is just not complete enough, really. I felt bad about, man, because I missed some stuff that I didn't need to miss on the test. But it was also the hurricane, whatever, a bunch of excuses. I was stressed out. I was like, let me submit this thing quickly. But I should have waited. So no, I'm trying to preempt that with this coding challenge. I'm like, I'm gonna get a good template so that I can build this thing out like real fast. Just get used to doing everything and kind of have the right tests I want to write, the idea of the tests I want to write already ready, so that when I'm on the clock, I could just do it.
Mm-hmm.
So yeah.
Cool. Yeah. Right. Exactly. I honestly, I would say look at, as you're learning Python, look at doing that, because look at writing tests. Because not only will you write tests, but again, you're kind of teaching yourself, it forces you to state ahead of time what you think something does. So write a test. I mean, it's for yourself. It's to communicate to yourself. It doesn't have to be super quality, but be like, when you're learning list comprehensions, and when I pass blah and blah into this, it's going to do this. And then you write the test, and then you're like, oh, it doesn't do that. Now you get to investigate, is it because I wrote the code wrong, or is it was my expectation wrong? But it again, gives you like a nicer canvas to triangulate all that, and like a structure for it that you don't really have when you're just typing stuff into a console or running script files.
Interesting. That's great advice.
Yeah, like that's very much what I do when I'm like learning stuff. I'm like, I've got like I use org mode, but like I've got a file where I'm like opening, running it, and like I usually like even write up a table of like expected inputs and expected outputs, and I feed that table into my program and like try to get everything to match. Like, okay, and then like have an output, like what the expected output was and like what I actually got. So
interesting.
And then just byproduct, you learn PyTest or whatever the default testing stuff in Python is.
Right.
Speaking of Python, Guido van Rossum just joined Microsoft, Claudio.
Who's that?
Guido van Rossum, the founder, the creator of Python, who recently retired. He just joined DevDiv.
Interesting. Huh.
Yeah. He got bored of retirement and joined DevDiv.
Yeah. That is very interesting. I hadn't heard of that.
Yeah.
All right.
The other interesting part of that is apparent. Like I would assume that what that meant is that they just had an open invitation extended to him. Like, if you come over, Kier Guido, we will find the budget for you.
Okay.
Wow.
That's pretty cool.
Very cool. Yeah.
Very good.
Yeah. So let's see. One thing that I wanted to bring to talk about. So this I decided to just spend a little time, like literally just an evening watching YouTube videos and stuff like that, but like learning actually about GPT-3 and how it works and all that. And I am actually more excited and more bullish on it than I was before.
Sorry, hold on a minute. GBT? What's that?
GPT-3. So the AI thing that came out recently that everyone's all talking about because it can generate language. It can generate text that's actually really good. Like it can write articles and stuff like that. They're almost indistinguishable from humans. So yeah, I'm starting to see the outlines of why it will be a big deal that will matter. This is hard. Like I'm pretty cynical on this stuff. I've heard these claims before, but so first of all, I guess to say not specifically GPT-3 because it is very good and it is very cool. It is also something that only OpenAI can really run at this point. But should I step back and kind of like describe what it is?
I was gonna ask you. I'm just like searching it up, and I cannot like find something.
It's GPT-3 or without the dash. Yeah, it'll be all over the place. Like you can, yeah. Yeah, you can find videos of people like doing interviews with GPT-3, just like with a video generated avatar. And it's like good, like it's having like a real conversation. And so, and I mean, like I am far from an expert. I'm just kind of rehashing kind of a couple conversations I've had and what I've gleaned from watching Computer File series on it. But here's the deal with that. Like, so GPT-3 by itself is pretty cool, but it shows the way more than anything. So if you kind of know how neural networks work, I mean, it's basically a bunch of these mini computers, and they're not really even mini computers. Each neuron is just like a freaking equation. You send in inputs, like numerical inputs, usually just a 1 and a 0, and then it either fires or doesn't fire. It gives like a range between 0 and 1 as an output. And then, and that's not impressive at all. That's just a function. There's some curve in there. What's cool is when you wire all these up and then you start feeding example stuff and feeding stuff into it and getting output, there's an algorithm called the backpropagation algorithm that basically you can use to adjust the shape of those curves and those equations, the parameters for it, that implicitly kind of makes the network start memorizing the inputs in its connections. Like, and that's just like the basics of how neural networks work. Thank you, Jinping, circa 2003. I can't believe that's still coming in. That learning that paid off. So like that by itself is pretty straightforward. People use it for all sorts of stuff. It's very, very basic pattern recognition. And one of the big problems with it, you need massive amounts of data to train it, which is why I'm like, it's not super useful to most businesses because most businesses don't have that much data. Like your couple million records are not even the beginning of it. And of course, that's like really, really far from like something being able to have a conversation with it. So kind of the next level from this is like, okay, well, how do you create something that can like generate text, right? So the simplest level, like we've had these since the 70s, I believe. It's called Markov chains, maybe even longer, which is basically you analyze all the training text and you just build up a gigantic freaking probability matrix where like for each word, if you see this word, what is the probability of this word coming after it? What's the probability of this word coming after it? What is the probability of this word coming after it? And you can like start it off on a word and just follow those probabilities, and it makes you a sentence, kind of, sort of. So because neural networks also are kind of are encode probabilities and probability distributions, like you can also use them in this way. The problem kind of becomes, well, you have to, at some point, in order to speak English, you have to understand the structure of language, which means like, you know, when I say, you know, Dan walked into the store and he bought a Kit Kat bar, by the time that I say the word "and he," you have to remember that the first word was Dan, and therefore, and is usually a male associated word, right? You can't just go from word to word to word, and you have to have that memory. Mm-hmm. So there have been all sorts of models where basically people are doing stuff like saying, okay, well, the neural network, it's getting like the word passed in, but then what it spits out is the next word and then some sort of memory vector, and then the next time through the neural network, we're passing in the word and the memory vector, and just kind of circles back in, so there's kind of a memory sort of thing. And that kind of sort of works. It doesn't work super well. There's also tweaks you can do. So in around 2017, this concept came out. Well, the concept came out earlier, called attention, and it's a pretty darn simple thing, and says, well, one of the things that the neural, like let's say that the neural network does, is it has access to the full text, right? It has access to the next word, and then it will calculate where in the text it should look in the original text it should look in order to generate the next word. And then around 2017, this paper came out, which was like, really, you don't need to like this technique combined with all those other techniques. Like if you go just with this technique, that should be good enough for a whole lot of stuff. And that's the concept of a transformer. I believe that's the T in GPT. So it's a really, really neat idea, mostly because it's super simple. Because it's so simple and doesn't have the sequential thing in it. It's parallelizable, which is always a huge, huge deal when you're talking about this stuff. So then what GPT is they basically took this idea and said, all right, well, we'll just we're just going to train it on like all the data from Reddit. Like every article linked from Reddit. Those are articles that represent the English language, sure. And, you know, increase the number of neurons so that it can kind of store all that. So they did that with GPT-2, and what they found is like, oh, like it performed really, really well on all these benchmarks. All these, because with this attention technique. And what you expect is like, you know, you keep throwing more hardware, more neurons, more training at it, and at some point it's going to even off at how well it's doing on these benchmarks. Well, in GPT-2, it didn't even off, so they were like, okay, let's throw more hardware at it and more training at it. So they did that, and that's what GPT-3 is, and what they found is it's still not evening off. So that's where it's kind of a big deal that like you're looking at that and like, all right, well, where can it go, right? I mean, so what GPT-3 is because it's just trained on the internet. It's just this model which somehow inside of it understands how the English language works, right? So now you can take that kind of starting point and do like a secondary training for specific day, for specific actions or something like that, and it could learn how to be asked to do something and then provide an intent, right? And understand what you're intending and what you're trying to do. So that in itself is pretty cool, and I can understand that being a big deal. The other aspect of this is, well, if the idea of transformers scales that well that we don't even exactly know where it's going to top out. I mean, it'll top out at some point, right? It'll top out at some point before, you know, you get a fully sentient thing, but we just don't know where it is yet. You could do it for other stuff. So like for example, you could take a network of transformers and train them to write a Lisp program. So like, and I say Lisp, because Lisp almost certainly it is an abstract syntax tree. It's pretty easy to generate Lisp programs that work. It might not be the sort of thing that is easy enough that at that scale makes enough of a difference. Like it might be just like, oh, we'll just increase the order of magnitude by 10, and now it can do any language. But like, you know, I'm gonna start with Lisp. So let's say you did that, and so you got it to understand the semantics of Lisp, and then you could train it just on inputs and outputs, but not to produce those inputs and outputs, but to write a program that would produce it. So what potentially you would get in the end is a program that produces the outputs you want, given the inputs that you want, that is understandable because it's written in a programming language that humans can understand. And of course, you can tweak it further, make it understand what understandable programs look like, right? So that's like a really interesting concept. I'm sure it'll be difficult to read, but for a sizable category of software, you could imagine that just being the way to go because that's way more efficient, right? And I mean, like, and that doesn't address kind of the TDD problem where like most people don't know what they want, right? That part will still exist. That part is still going to be worth putting your time and effort into. But like, I'm starting to see this outline where like, okay, so like 10, 20 years down the line, this is what this stuff could look like, right? Where our teams have like specialists who are training these networks, who are and really we're just kind of interacting with these programs they're creating, and they're creating their intents, and it's pretty normal for almost any team to have a specialist like this. And also a decent amount of software developers will naturally make the jump to being one of those specialists. So I don't know, that's kind of been like the thing that I got excited about this earlier this week. And I think, all right, I was skeptical about it, but I think there is definitely something there.
Interesting. You know, thanks for the rundown on this. I was not aware at all of all these things. So I've already opened a couple of links here to do some more research later.
Yeah.
Because to me, it's like, okay, I need to immediately relate to the concepts to see how it applies to, you know, my context, my skills and knowledge and what have you. So one thing that it came to mind is I use the web version of Outlook, and I've noticed maybe the last month or so, I've been noticing that as I'm typing, right, it is like showing the next word, right? And it's like, okay, it's trying to predict what I'm going to write. So, I mean, yes, there are the benefits where if they get the word right, I can just hit tab and I don't have to type. But at the same time, it's making me slow down because it's like, what is it going to tell me? What is it going to tell me? Instead of letting me, you know, go through my thoughts. So that's experience. Right?
I think on a phone it's a little more useful when you're like one-handed, but yeah.
Yes, exactly. But when I'm sitting like on my computer and I'm typing and I'm looking at the screen and it's showing like the next word, it's like, are you trying to get in my brain? It's like, you know, I don't know how I feel about it. Also because in a way it's trying to make me more efficient, but when I slow down, when I pick up pen and paper and I'm writing, now it's making me harder for me to like even think, how do I spell certain words? Where it's like when I'm typing, because of muscle memory, I don't think about it. I get the spelling pretty good, but when I'm writing, it's like, oh, now I don't have the muscle memory of the fingers to spell certain words. So it changes the way I'm thinking about things based on where is it that I'm producing that output.
Yeah.
So, you know, I don't know how it relates to everything you just explained, George, so I apologize for that, but it's like what came to mind as I'm thinking through all of this, right? Like what good can come out of it? How can this be used for good, right? And what kind of problems is it gonna actually bring along with it, right?
Well, a lot of this stuff has already brought problems, and the inscrutable algorithms thing is rough.
What's inscrutable algorithm?
So like when you have, I mean, there's a bunch. I don't want me to imply that neural networks is the only way that ML is done. There's other ones like and training them is not, like with lots of data is not the only way it's done either. There's adversarial stuff and so on. But you know, as long as you're training stuff, right? You don't necessarily always, you get a box that basically you can put an input to and get output, and you don't necessarily always know why.
Hello, welcome to Azure Communication Services audio testing system. To test your call quality, record a short message after the beep, then the message will be played back to you.
Remove from call. There we go.
What is that?
I don't know. Someone did that. I booted it. Someone added a
booted.
Yeah. Someone was playing around with the settings and did that.
Right.
So like for an example, like there was, a much maligned pilot program down in I think it was in California, where one of the courts, they used an AI system to decide who gets and doesn't get parole. Like they put in a bunch of factors around the person. It's kind of predicting recidivism and all sorts of stuff like that, which is probably, I mean, like it is, like they demonstrate statistically accurate, but that's still like what's the, like that's still a moral issue when you're like, well, why did this person get a parole and this person didn't? And they're like, I don't know, computer said so, right? Like that's an ethical problem, even if like the overall effect is better, probably. Which is that even that's like hard to measure because you never get to measure what actually happened against what would have happened otherwise, right? So like, like that's the sort of thing that would mean inscrutability, right? So you've got these AI systems that seem to work well, but you don't know why they're making a decision, and therefore that really limits to how much we can apply them, like from an ethical standpoint, to certain types of problems in our lives. Not to mention from a safety standpoint, like you train an AI system to run stoplight timings, and you view it for 1,000 hours, and it always gets it right, and it seems to be really, really good and much better than what you had programmed before, but like, you can't be sure it's not ever going to get like 2 red lights at the same time. Like you could have layers to it, of course. Do that. Like so that's kind of the big problem, and that's kind of the interesting part where you could say, well, like, what if it can write a program that will do it? A program that can be read by a human. Well, a program explains all the steps, right? You still have to read the program, and it's still a pain in the ass, but it's less of a pain in the ass than figuring everything out and writing the program in some situations. So there's definitely an angle on it that's pretty cool from that point of view. Yeah.
That's super interesting.
Yeah, and some of this stuff is just like for tools. So like if you go back, one of the things I really love doing is like reading like old papers from like the 60s and 70s, like all those guys, because like they're talking about what they imagine the future will be like, where they're imagining it'll go. So like one of the fathers of personal computers, J.C.R. Licklider, he founded DARPA, and most of the research, right? They funded that. They funded my graduate school thesis. He has a series of memos that he wrote when he was at DARPA, like kind of laying out his vision for in the 60s, late 50s, early 60s, I think, about like what his vision of where personal computing will go and what the relationship between humans and computers is going to be. And it's really interesting because in a large degree, a lot of it is really, we're not there yet. And he's talking about how like, well, when people are talking about solving a problem, a large part of that conversation, especially if they're remote and talking on the phone, but even if they're in person, is formulating a shared mental model of what the problem actually is, what the constraints are, and so on. So his vision was like where the computer would be central in that, in visualizing the models that people are talking about. Well, now it's visualizing 2 different things, generate 2 different mental models. It's encoding the mental models you're talking about, and it can show you where the differences are between what you're thinking about and what the other person is thinking about. And like, now that you're starting to get to a point where you are seeing systems that can kind of understand natural language in what seems to be an interesting way, like we could start working in that direction, right? Especially when it's something like, okay, generating visualizations, right? Generating tools for development, like that's not a life or death thing. You've still got plenty of chances to audit and make sure it's doing the right thing. Great. There's a tool someone wrote right away where they trained GPT-3 to where you tell it like just in English what you want to do with your cloud infrastructure, and it spits out like the AWS CLI commands for it. It's like, oh, that's really neat. Like, because there's about a gajillion of them, and they're all confusing. Like, I mean, heck, that's even good for Git, right? Because Git's freaking annoying in 50 different ways. So like tools like that, I could totally see being really neat and useful, and you still have to learn the other stuff, but it's gonna work. It's gonna be a helper to help you actually do the lookup and build all the stuff, and maybe you can write some bits of code for you as well, right? And say like, all right, I want a loop, but do it in with using recursion. And as you go over the object, oh, I want it to go asynchronously every between half second and quarter second, but put down like a bell curve. Like you could say that, and it could actually generate that for you. And it's still faster for me to say that than to write the code to do it, even though I know how to write the code to do it. So like that'd be pretty good. Small scale, right? You still need to be able to audit what it generates. But like that, like would love that sort of developer tooling, and that's completely in line with the sort of stuff that like JZR Licklider was envisioning. Yeah. All right, I've monopolized a lot of time.
You're making us
it's interesting
that's
stuff.
it. Yeah. And I have to throw a range there because thinking about like how we make these connections, right? And of course, George, you are going to be able to speak to this even better than me. When I did my improv sessions, classes early this year, one of the exercises that they gave me was word association, right? So going around the circle, and at first the instruction was, person in the group will say one word, the next person should say whatever word, no association, just whatever word comes to mind. And the common behavior, you would see some people would be like thinking really hard. And it's like, why are you thinking so hard? It's any word that comes to mind, right? And it's like, well, is the person trying to be funny? Is the person trying to not sound stupid? Even though it's like, dude, whatever word, it doesn't matter, right? And then the next part is, okay, now let's do with association. Anything that comes to mind, as long as it's associated with the word you just heard. Right? So then it starts developing along those ways. And then eventually, like the coach gave us a slightly different approach where you hear word A, you think word B, you say word C. So for instance, one person might say dog, I may say bones, I may think bones, but then I may say grave. And then the next person may pick on that and say, I don't know, may think prayer and may say church. And then it's like this overall context being built. There's absolutely no way to know where it's going, right? How do you predict what the final scene, what the final story is going to be out of this, right? So I don't know. It got me thinking about these things, like how far can you predict? What kind of context do you need to put together? Because maybe if you hear like dog, grave, you think pet cemetery, and you start developing from there. I don't know, right?
Yeah, right.
But
right.
I don't know. It got me thinking about those things, man.
Yeah, that's the sort of thing like what we're always trained. Like that's how you like build a scene and build a show. Like you always go 2 steps away with the association, 3 steps away, and then kind of let it play out, and stuff just tends to meet in the middle, right? Like if you've ever done the Herald form, like that's what it's all about, right?
Right.
It's like you build up a show from that, and then just usually what happens is your last scene is like some crescendo that happens to stitch all these things, the threads together, like half the time, and people are like, "You're a genius," and you're like, "I don't know, brains work that way."
Right.
Yeah, no, absolutely, but that's all about prediction, right? Like, not everything has to be about prediction. If it's just understanding what you've said, well, people tend to say things the same way, and you know, that's why you wanted to give you that output. Right. Actually replacing people, I mean, not every person is that brilliant. Like, you can replace a lot of people, but but I mean, I'm not talking about that. Like, you don't really need to do that in a lot of ways, and it's not necessarily going to be cheaper to do that in a lot of ways anyway. But as an assist to just make stuff that's annoying and hard easier, to decrease misunderstanding, which is like the bane of every conversation, like there's really, really cool things that can be done with that, right? I mean, just really imagine, like the explanation I gave just now of how transformers work, like as I'm saying, something is building up, like a visual diagram of what I'm saying. First of all, so I can kind of see it and adjust on the fly if I kind of say something wrong. But then you say it back, you say your understanding back, it builds up a visual diagram of what I'm saying, and then automatically diffs them in a way that we can see. And it's like, all right, well, so you can see right, I mean, like as a learning tool, how cool is that, right?
Mm-hmm.
So, you know, we're talking about 10, 20 years out, but that's still well within the career of all three of us.
Yeah.
4 of us. Tony's on here too. Hey, Tony.
He's quiet. His avatar is dark.
Yeah.
He's Batman.
Yeah, that's right. Hey.
That's cool.
I'll be right back, guys.
Yeah.
All right.
Yep.
Yeah, that's interesting. Actually, that goes along something that I was sketching out to share here. Let me share my screen. Share real quick. So this morning I've run into this blog post around event storming, which I read through. It's like I like how the graphs that they use to explain the concept, and they get very basically through like a DDD, you know, bounded context and aggregates and things like that. But anyways, there was one line here that I highlighted. Not that one, up here. Your software systems more accurately reflect the true nature of your business, which took me to a conversation I've had recently where we were talking about like the label that should go on a button in a certain screen, and that label could be cancel. So like what do you guys for? Say you go into some sort of screen and you see, oh, purchase, and then there's a cancel button there. What would you infer that does? What is the mental model that comes when you see cancel there?
Right. And so I would think that you're not making you had queued up to make some purchase, maybe in a shopping cart, and you're kind of canceling the shopping cart, which should clear it.
Okay. What about if, say you are taking that order on the phone, right? You have the client on the phone, the client's starting to make a purchase, you're, you know, all done, you submitted that purchase. For 13 minutes or 30 minutes later, the customer calls back and tells you, hey, I would like to cancel my purchase.
Okay. Yeah.
Right.
So that purchase is an entity that exists. And you're,
right.
Yeah.
So then, exactly. So thinking back about this that blog post mentioned, right? Your software accurately reflects the true nature of your business. So if we see a cancel on the screen, does that talk about the business activity of canceling a purchase? Or does it mean the last action that the user has performed that he wants to maybe discard the changes, right?
Right.
So we got into like a long discussion just to figure that bit out, right?
Because we have like a common visual language around it, but it's, yeah, it's not exactly correct, I would say.
Right, because it's like, as far as I remember, like historically from like 25 years ago when I started into software, it used to be that we would go to this screen where everything was disabled. We could read the information, and then we could hit an edit button, which would enable controls where we could make changes. And if we were unhappy with the changes or what have you, we would hit cancel to just discard those changes and go back into viewing mode. That's how we've learned to see like the cancel word in software, but that has nothing to do with the business,
No,
right?
it's just visual language. Yeah.
It's exactly. So that was a good conversation about that, like the understanding of words and context and what multiple people will understand when they see that on the screen, right? Good stuff.
All right. So I have a question for you, Claudia.
Mhm.
So let's say you're interviewing someone who is junior, right? You ask them about solid development principles. They don't know what that is. Do you find that disqualifying? Do you think that does that just merely count against them? Is there no change, or does it like not count against them, but it would have counted significantly in their favor otherwise, or would you never ask it?
You would ask more as, okay, let me just see if the person is aware of the thing, have heard of it. And then if the person does not know, that is okay. If the person does know like how to spell out the acronyms, that's fine. If the person can speak to it, like, okay, this is where I've seen that violated. Oh, that's even better. But I would not disqualify it because I've interviewed folks who are like experienced developers who have been doing this for years, and then I asked about solid principles. They're like, "Oh, I have no idea." And then I hint at some problems, right, that surface, like a violation to SRP, for example, and then the person talks me through, what the problems are and how it would be addressed. So it's like the person knows it, doesn't use those vocabularies like, oh yeah, here we are violating single responsibility principle, or here we are not doing dependency inversion, right? So I would not count that as like a hit on the person. Knowing it, it's like patterns, right? If you know what a strategy is, we don't have to be talking about it. We can move on the conversation, right? So for me, it's more of a gauge, if anything.
Yeah, that's largely the answer I've gotten as I've been asking the people. Because that's one of the things I'm like trying to figure out. Like it kind of, there's like a room for a lecture or two in our, especially around architectural concepts in our curriculum. And I'm thinking whether it's something like that I should add in, or perhaps just on a higher level, a discussion of what is good code, right?
Okay.
Because like that's kind of a difficult thing to talk about. I'll actually, Max, how about I put you on the spot? How would you define good code?
Man, that's a great question. And that was actually, what's interesting is like that I thought, we kind of learned as a preface, we kind of learned the development, how to write good code. It's like certain principles, like, if you repeated something, you should be able to refactor it and just use it once, or stuff like that. But, in our program, it wasn't so much enforced as I think I could have taken. I think it would have been nice to have a little bit of code review. I understand we write a lot of code. It's probably not possible to read it all. But for me, okay, let me try. Good code, mostly just like the way we were taught to write was, from what I understand, more of like a functional programming approach where like data comes into the program. This is what I understand of it. Data comes like into your program and it like flows through. It stops at like the highest point. It's like kind of cloned pure methods, I guess, and like your functions manipulate it as it goes through like the different functions, and you receive an output. So for me, it would be like, yeah, of course, not repeating code, maybe not using like boilerplate code, like, loops, stuff like that, unless you have a really good reason to, but using some of the higher order methods, kind of refactoring as much as you can into different functions so that when you look at the solution, it looks really clear and you can follow it. With the good naming conventions, you could say, oh, this was done here, that was done here, that was done here, and not have a result. So I guess, I don't really have a great idea of what good code is, but that's just, like I said, that's how I'd answer it. I don't know.
That's not a bad answer, and actually I like the preface you gave to it. So, Claudia, how do you define it?
I like, of course, nowadays we don't recommend Uncle Bob's Clean Code book much anymore because of certain things that are there, but I remember specifically where he starts the book that he asked a bunch of folks, what do you think of when you think about clean code, right? And some of the answers that came out, it does resonate to me. You find like functions, methods, classes, what have you, that the name does not give you any surprise as to what they should have. So if you have a get customer method, right? Well, you wouldn't expect to look into that method and see that, well, if the customer does not exist, we're actually creating one and giving you a brand new one. I was like, no, that's a surprise. I didn't expect that to happen, right? So, things are named properly based off of how we naturally think about things. So I like code that allows me to read it and think it in English as opposed to the programmatic terms of things. Like, I don't want to read about all of the technical aspects of things. I want to read it from a human standpoint, right? And it's like, when I'm reading this code, how does it relate to the problem at hand, right? So I don't want to necessarily see what is this code doing, how is it doing. I want to understand why is it doing whatever it does, and then allowing me to, find the individual parts that compose the overall solution. So that's what I think of good code. Of course, avoiding repetition, properly naming things, putting a lot of thought into how do you name things. Does it actually make sense? I spend quite a bit of time just figuring out what words to use to name things. Right? So those are things that come to mind.
Yeah. So for my answer, like I do always go back to intent, like code that someone who reads it later can understand what the heck I was intending to do.
Yes.
Because, and I'm kind of split on whether to even include in the definition that it actually addresses the problem at hand. Because like any number of times, most times, I don't know, I've written code that doesn't actually do exactly what it was meant to. But if I've written it but it's not necessarily bad code because of that, right? I'd be saying all my code is bad code then, which is very humble, but like I don't think is true, nor helpful if that's the definition. But at the same time, if someone can easily understand what I was intending to do, and they have an understanding of what it should do, then that makes the problem for them much easier, right? And it's all kind of ties into that maintainability angle, where, well, good code is how maintainable it is, but then I don't want to just answer one term that needs definition in terms of another term that needs definition. So both good code and maintainable code, that's kind of how I define them, where it's like how well that it's on the scale of how well it communicates what the frick I was trying to do when I put this together.
how quickly, when I look at the code, how quickly can I feel confident making changes to that code? Right?
That's a good metric. Yeah.
Yeah.
Although not all changes are born equal, so you kind of
True.
might be worth specifying, right?
Right.
Like, I wrote a function the other day where it was really just like a function I needed it to check a queue every like half a second or something like that. And so like first pass, I kind of wrote it, just that run the function, set timeout 500 seconds, run it again. Actually, I did write that eventually. The first pass, I actually wrote it as kind of a little more of a generic thing where I call the function, did it what I needed to do, and then waited 500 seconds, and then like I had passed in a parameter of what the next thing to do is, right? So like wait 500 milliseconds, and then call the next thing to do, which means that when I start it up, it's a little more complex because I have to invoke the function with a parameter of a lambda that invokes itself, right? Because the next thing that it does is that, but then after that, it just kind of runs and it works. But then I did end up, and I was like, yeah, this is actually good because like if you need to put different things on, like where like, okay, it does this and then it does something else and then it calls itself again, it becomes really, really trivial to make that change. And then I was like, man, I'm okay, delete that, simplify, because I don't I don't have a need to do that right now. And I don't have a good justification for why I'm setting myself up for that situation, except for like some neurons happen to find and make me think it's a good idea. But like that, I think that would be a counterexample to what you just said, where like if I had gone with a more complex thing, there's a whole wide category of changes that you would see and you'd be like, oh yeah, that's super straightforward to do. Whereas if you wanted to do that with a code as is now, you would then have to like, okay, try to think about how to do it and probably refactor it to what I had before. So yeah, like I think that there's some good counterpoints there.
Sure. Yeah, because it actually goes back to, say, thinking of solid, because depending on the nature of the change, quote unquote, it may be something like, well, if, open-close principle has been observed here, then it's not going to be a change, it's going to be an addition to the system, right? I just need to write new code, and, how quickly is it for me to identify, okay, do I have scenes in here in the code that I can actually tap into to just add code to it? Or no, it's really a change to an existing feature. And then at that point, well, okay, how well structured is the existing feature? Is it documented through tests? Do the tests actually describe the whys of the solution, as opposed to just, okay, we have these classes and you have to call into this thing? All those play into me like feeling confident with working with that code base. Great question. I took note of that. This is good stuff.
Cool. All right, and I think we are 1 minute from time.
That's it.
Quickly.
Great conversation. I hope Maxwell got some good stuff out of it. Hope to see you back. Times.
Yeah.
Awesome.
Yeah, it's great. Thanks for having me, guys. Yeah, it's great to get a sense of, joining the community and kind of like what you guys talk about, what you're thinking about, what's interesting to you. And it's good to feel part of something larger than yourself too. So, I'm happy,
I know that's one of the reasons why I do this. And I know that George is the same, with community activities and things like that. And Tony, I know that Tony is pretty quiet over there, but he's also, like the one of the leads in our local user groups here in Houston. So this is what we're here for, man.
Cool.
Yep, every Thursday.
Every Thursday,
Cool.
Let's grow the community.
Yeah.
All right. Cool stuff, man. Thanks for joining in, participating in the conversation, and I hope to see you guys all next week.
Bye.
You guys have a good one. Bye.
See ya.